All right, in this video we're going to talk a little bit about friction at the microscopic level, and in particular why it is that the static coefficient of friction is larger than the kinetic coefficient of friction. So what I have here are two surfaces sort of at the microscopic level, and so the top one here, surface 1, is being pulled to the right, and surface 2 is just kind of sitting there. So you can think of this as maybe a box and a table or something like that. And what you can see here, I'm going to use the blue to sort of distinguish where they are contacting each other. So we have these little bits of sort of microscopic roughness, right? These are the atoms that are sort of sticking out a little bit. And it's true of both materials as it moves across the surface. These are actually have a special name. They're called the asperities of the material. And they just sort of stick out and run into the other asperities from the other material. And so you can start to see, like, as these two electron clouds sort of run into each other, they push on each other and they stretch the bonds of all of their of the entire material, especially the parts that are closest to the surfaces. So you can think of this, if you take your fingers and sort of run them into each other like this and push against them, right? The bottom ones here are pushing back on the upper ones, and the upper ones are pushing on the lower ones as they move across. Now that pushing takes a lot of force to actually get the lower and upper bonds to yield a little bit. What happens is they sort of tip over and bend down. And when they bend down and yield like that, that's when the object begins to slide. Because they're bent down now, the contact interaction, the force that's required to run roughly across those two surfaces, is much lower than it was before. And so at the microscopic level, you can understand the differences between these two values, the static and the kinetic frictional coefficients, by thinking about how hard it is to push the asperities over. But once they yield, they're very easy to push across. And so the force that's required to push across once they yield is pretty easy. And so the model that we use at the macroscopic level characterizes the ease with which we have to push across these two materials using these coefficients of static and kinetic friction.